This whole chapter is going to deal with percents in one type or another. So even though the basic percent type problems you've seen since you were in grade school, there's just probably 5 or 6 different ways that you could solve these problems, and all of them will give you the correct answer, and there's nothing inherently wrong with any of those methods. But with the problems that we're going to have to do a couple of sections from now, there is a vocabulary or a way of thinking that will be most useful to tackling those more difficult type of percent problems. So for these problems in particular, I don't really want the goal to be, I'll just do it my way because I can get the right answer. The goal here is to be able to analyze the pieces of the problem when they're in their simpler form, so that it'll help you more when we get to the more difficult problems coming up rather quickly. The basic form of a percent problem is percent times one number, times a number, is going to equal another number. In all our problems, we're going to be told the percent. Now we're going to be told one number, but our goal is to figure out which of these two numbers is given to us in the problem. Well, when we actually work a problem, we don't use a percent in a mathematical expression of any kind. So we want to take our percent and we want to change it to a decimal. Now, the number that goes next to the percentage, call that the before number. That number is generally thought of as like your total. It's the number that you had before you took any percent of it. The number on the other side of the equal sign, that's our after number. This is the number that's generally thought of as like the part, not everybody, but the part we were talking about. It's the amount you have left after you take the percentage of your before number. So when I look at my 1,069, I'm trying to figure out, is that the before number? Is that all the people who were surveyed? Or is that the after number? Is that just part of the people who were surveyed? Well, the of gives us a clue. Newspaper reports that 44% of 1,069 people surveyed think the president is doing a good job. Well, that is the number before we took a percentage. So it goes over there, and to solve, we do what it says. Both numbers are on the same side of the equal sign, so I just multiply 0.44 times 1,069. Turns out to be 470.36, which we don't talk about fractional parts of people. So the answer, when we round it to the nearest whole number, is 470. In this example, we want percent times before is going to equal our after. We start with our percent, change it to a decimal. Now the other number in the problem, Barack Obama received 69.4 million votes. He received 52.9% of the popular vote. So how many people voted in the election? Well, is 69.4 how many people voted in the election, the whole number? Or is that just part of the people who voted in the election? That's just the part that voted for Obama, so that's the after number. That's the fractional part. So the number that's supposed to go beside the 0.529 is our unknown, so we use x. To get x by itself, we need to divide by the number with x. And I'll round to tenths because in the problem they had rounded to tenths. And 131.2 million is my answer. Now what I want you to get out of the past two examples is this. When the number that was given was a before answer, as on the first slide, I just went ahead and multiplied my percentage times the before number because the number that was going to answer the question was the after number. So percent times before equals the after. Before gets multiplied times the percentage. I don't really want to have to do a lot of algebra in this class. So this setup for the after number shows you in specific terms what happens. If I know my percentage and I know my after number, then to solve for the before number, I'm going to have to divide by my percentage. I want you to get to the point where you can sort of shortcut this in your mind to where you say, okay, if I've got a percent and I've got my after, no matter what those numbers are, after means I'm going to have to divide by my percent to solve the problem. What I'd like is for you to just have to do that part on paper or in your head without going through the equation. That's your goal. That's the thing that's going to make next week's problems a little bit easier. So please try the practice and write them out if you need to. But remember, your objective is not just to get the correct answer, but to try to figure out before you do the work, is this going to be a multiplication problem or a division problem? Based on examining your number and deciding, is that a before number or is that an after number?